Hello, my name is METİN. This is 312th part of explanation of my theory. According to my theory and my formulas, ionization energies are at rest electron positioning tools in atom traps. Precisely, certainly, ionization energies are at rest electron positioning tools in atom traps. We can use as a tool, and I apply it. Yes, the best electron trap is the atom. The atom immobilizes the electron at ground state. Atoms are nests of at-rest electrons. Atoms are trapping houses of electrons. How the nature confine an electron and make it at rest, so how we can touch on its point at its certain position without disturbing it. Heisenberg's uncertainty principle is wrong. Before all of this, I want to show you how I predicted sodium atom spectral lines line by line precisely. Schrödinger equations, quantum theory cannot do this. At first I want to show again this. Left side, my computation according to my theory and my formulas. Right side, National Institute of Standards and Technology laboratory data, observation. If you are looking for proof, that is one of proofs of my theory. Here, left side, mine. Here, right side, observation. First page. If you are looking for proof of my theory, here is one of the best sodium atom spectral line. I have computed, I have predicted according to my theory and my formulas. Here, first page. Second page, look at that. Consecutive, 16, 30, 15, 47, 15, 46, 15, 45, for instance, line by line. Coherent, so coherent, okay? here. 16, 69, 16, 62, 60, 59. Right side observation, left side mine. Then notice consecutive 16, 49, 48, 47, line by line. Results are the same. Sodium. Certain deterministic theory. My theory is certain and deterministic theory. There is no probabilistic point particle trace wave-like. No. Yes, these are waves. Okay. Results are waves results. Yes. Here. This is my formula. Lambda EI represent an electron in an atom. Each electron has different wavelength. There is that these electrons are not identical particle, contrary to accepted physics. And ionization energies. This is data from Wikipedia. Ionization energies of the element data page. Okay. Sodium, 11 electron, 11 proton, and each electron per proton, 1 electron per proton, and each ionization energy represents a different wavelength electron, three-dimensional. Okay? Here from NIST, again NIST, National Institute of Standards and Technology data, they apply first ground state energy and second ground state energy to make spectral lines of sodium. To make spectral lines of sodium occur. Okay. Here, first ionization energy used 5 points. This 47 point. This. Okay. And they leave from these electrons. These ionization energies represent different wavelength electrons also. Then, when ionized, these electrons start to affect by their successive waves remained electrons, especially last one and this one. Okay, this is National Institute of Standards and Technology. This is Wikipedia data. Okay. Wait a moment. Now, this line, 37 0.6 spectral line produced by, I'm so sorry, this electron, which is lambda EI sodium 10th electron is equals to wavelength 0.846 nanometer. Okay, this electron make this. When we put 0.846, my formula, smaller wave number, greater wave number. When we put this, we gain single wave pulse, okay, and lambda, we gain this, as I told you before. And others, these 30.0, 137.5, 140 point, these are made by last electron. These last ionization, when we compute this, each ionization energy represents a wavelength of proton bound electron motion formed in an atom, and each one is different. Each electron size is different, each electron wavelength is different. Last one, 11th, lambda EI sodium 11th is equals to 0.7518 nanometer. This one. Okay. This one. Last electron, smallest electron in sodium, determines most of sodium atom spectral line. When we put this value 0.75 in my formula, we gain and N6 to 19, 12 to 26, etc. We gain absolutely certainly these numbers, and there is coherence between the two, NIS observational data and my theoretical results. Okay, so what means all of, what means that? What means that? Yes, how the nature confine an electron and make it at rest. So how we can touch on its point at each certain position without disturbing it. Okay. Experimentally, this is first, this is second ionization energy. And these ionization energies, all of these ionization energies represent, each one represents a different electron with different wavelength. When this 5.13 ionization energy corresponding electron ionized, okay, ionized as an electron. When an electron is free, it starts to produce and propagate successive waves. And these successive waves of 5.13 ionization energy represented electron, a specific wavelength you can account, affect, wave number is important, this remains electrons, but mostly this electron at first affect this one, okay, affect 10th electron. But second ionization energy, 47 point, corresponding electron removed, second electron starts to affect remaining electrons also, and mostly this second electron, ionized electrons, consecutive waves, and 1 and 2 and 12 and okay, affect last one, 0.75 18 nanometer wavelength sized electron, and these are the results. And at their ground states, we know their places. How? Now, 1. Absolute confinement places of electrons are atoms. In atomic conditions at absolute cold or ground state, electrons are at rest. Moreover, even at all